For basically all of human history, we've looked up at the stars and we've dreamed. But what was once pure science fiction is now becoming a real, tangible project. Today, we're diving into one of the biggest, boldest challenges humanity has ever decided to take on: the colonization of Mars. This one phrase, right here, really captures the powerful drive behind the modern push for Mars. See, this isn't like the space race of the 20th century. That was all about exploration and, let's be honest, geopolitics. Today's ambition is rooted in something way more fundamental: the long-term survival of our species. It completely reframes the entire mission from just a cool science project into an absolute necessity. So, here's our roadmap for this journey. We're going to start with the big why, the core reason we're even going. Then we'll get a reality check and look at the brutal Martian environment. After that, we'll break down the 7 biggest challenges we have to solve and the incredible tech being built to do just that. Finally, we'll see who the key players are in this new race and explore what it all means for the future of humanity. All right, so let's start with that fundamental question. Beyond just curiosity and scientific discovery, why are we really pouring unbelievable amounts of money and taking such huge risks to get to that distant red planet? Here's the bottom line. Our home planet, as amazing as it is vulnerable. You think about it: asteroid impacts, catastrophic climate change, even something like nuclear war. These existential threats are real. So the modern push for Mars is really driven by a pretty logical conclusion. To guarantee our long-term survival, we need a backup. A self-sustaining civilization on another world is literally the ultimate insurance policy for all of humanity. Okay, now that we get the profound why, we really have to ground this dream in reality. Mars might be our closest Earth-like neighbor, but let's just say that Earth-like is a very, very relative term. Let's take a hard look at the facts of what you'd actually be facing if you were standing on the red planet. And wow, this table just lays it all out, doesn't it? The gravity is only about a third of what we're used to, which is a huge deal. A Martian day is surprisingly similar to ours, but a year is almost twice as long. But look at the temperature and the atmosphere. Those two numbers right there, they show just how unbelievably hostile Mars is for human life. Let's just focus on this number for a second. An average temperature of -63 degrees Celsius. Let that sink in. That is so much colder than even the most extreme places on Earth. Sure, the equator on Mars can sometimes hit a nice 20 degrees during the day, but at night that same spot plummets, and the poles can drop below -140 degrees. And you couldn't even take a deep breath to complain about the cold. This chart just blows my mind. The air is almost entirely carbon dioxide. The oxygen we need to live, it's just a tiny, tiny fraction of 1%. Plus, the atmosphere is incredibly thin, about 160 times less dense than Earth's, which means it offers basically no protection from, well, anything. So, given that harsh reality, what are the biggest showstoppers standing in our way? Well, scientists kind of see them as a series of great filters. It's like a gauntlet of 7 massive challenges that humanity has to get through to build a permanent home on Mars. Let's break them down. And here they are. It's a daunting list, right? You've got the invisible threat of radiation, what low gravity does to your body over time, and the immense mental strain of being so isolated. And then you get to the practical stuff. Where do you get air, water, and food? How do you power a whole colony? And then, maybe the most profound question of all, can we even start a new generation on Mars? Let's zoom in on that first hurdle. Mars doesn't have a global magnetic field or a thick atmosphere like we do. Those are our 2 great shields here on Earth. Without them, the Martian surface is just constantly getting blasted by deadly particles from deep space and our own sun. It is a true invisible killer. Okay, now let's talk about hurdle number 5, farming. At first, it looked promising. We found out that Martian soil has a lot of the nutrients that plants need. But of course, there's a catch. A big one. The soil is laced with a toxic chemical. Any idea what it is? Now, facing all those challenges might seem impossible, but this is where the story gets really, really exciting. Because for every single one of those hurdles, there are brilliant people developing incredible technologies to overcome them. We're not just staring at the problems, we are actively engineering the solutions. So, how do you beat that invisible killer, radiation? Well, the answer is actually pretty simple and kind of elegant. You use Mars itself. The most effective strategy is called passive shielding. All you do is pile a few meters of Martian soil on top of the habitats, or you build them underground in natural lava tubes. It creates physical barrier that just blocks most of the harmful cosmic rays. Simple but effective. And what about air to breathe? This is where a little device called MOXIE comes in, and it is a total game changer. It's about the size of a lunchbox, it's on the Perseverance rover, and what it does is amazing. It literally inhales the CO2-rich Martian air and splits the molecules to produce pure oxygen. It's already worked multiple times on Mars, which proves we can generate our own breathable air, and, this is huge, the oxygen we need for rocket fuel to get home.
Yeah, making that rocket fuel right there on Mars is absolutely key for a round trip. The process is called the Sabatier reaction. Basically, you bring some hydrogen from Earth and you mix it with the CO2 in Mars's atmosphere. That creates methane, which is the main fuel for SpaceX's Starship, and water. Then, you can zap that water with electricity to get oxygen, the other part of the fuel, plus more hydrogen to start the cycle all over again. It's a brilliant way to live off the land.
Now, powering all of this needs a super reliable energy source. Solar panels are great, but Mars has these planet-wide dust stores that can last for months and just block out the sun. The trump card here is something called kilopower. It's a small, compact nuclear fission reactor that can provide steady power for over a decade, no matter what the weather is doing. This isn't just about convenience. It's what enables long-term survival, making sure the lights and life support stay on, even in the worst storms imaginable.
And remember that toxic soil problem? We've got solutions for that too. The culprit is a chemical called perchlorate, and it turns out we can literally just wash it out of the soil with water. Other ideas involve heating the soil to break the chemicals down, or even using special bacteria to eat the toxins. It's a process called bioremediation, and they could turn poisonous dirt into fertile ground. So with the problems being identified and the solutions being developed, the question becomes, who is actually going to do this? The dream of Mars has kicked off a whole new kind of space race, and this time it's not just between countries. Private companies are actually leading the charge. Let's check out the key players. It's fascinating because everyone has a completely different philosophy. You've got NASA taking this very measured, step-by-step approach. Their Moon to Mars strategy is all about using the moon as a training ground first. Then you have SpaceX, which is going for a much more aggressive, direct path, betting everything on their fully reusable Starship to make colonization affordable. And then there's China, which is executing this very methodical, long-term plan focused on hitting key milestones first. It creates this amazing dynamic of competition and even potential collaboration that's going to define the next decade. And you know, this isn't some far-off future fantasy. Just look at this timeline. Japan's MMX mission to the Martian moons is planned for 2026. SpaceX is aiming for the first humans to land around 2029, with both NASA and China targeting their own landings in the 2030s. The historic moment that we have dreamed about for centuries is potentially just a decade away. Okay, we've talked about the why, the how, and the who, but as we stand right on the edge of this new era, we have to face the final hurdles, the ones that you can't just solve with better engineering. These are the deep, difficult questions about the cost and, more importantly, the ethics of this whole grand adventure. The cost of building a self-sustaining city on Mars, it's estimated to be in the trillions of dollars. But what's even more profound is the ethical principle of planetary protection. This is the critical idea that we have to prevent contaminating other worlds with life from Earth, and also protect Earth from anything that might be on other worlds. If Mars has its own native microbial life, no matter how simple, do we have the right to risk destroying an entire alien biosphere? It's one of the biggest questions we have to answer before we ever set foot on that planet. Ultimately, this journey to Mars isn't just for astronauts and rocket scientists. Every single one of us is a living witness to a pivotal moment in human history. The decisions that are made in the next few years will shape the future of our species. So the final question really isn't just for them, it's for you. As you watch this incredible story unfold, what's your role going to be in shaping humanity's next great adventure?
Welcome, challengers, and welcome back. Today, we're doing something a little different. We are going to put your knowledge to the ultimate test. This is your shot to prove you really understand what it's going to take for humanity to make its next giant leap. So, let's see if you've got what it takes.
You know, this isn't science fiction anymore. It's happening right now, as we speak. The journey to Mars is shifting from a far-off dream to a real-world engineering project. We are literally standing at the doorway of becoming a multi-planetary species, and the questions we're about to dive into, they're the exact problems being solved in labs and on launch pads today.
So how well do you really know the plan?
This is not your standard multiple choice quiz. Nope, we're going deep, one question at a time. If you can nail a perfect 10 for 10, you'll officially earn the title of Mars Colonization Master. So are you ready? Let's do this. Okay, first up, a really foundational question. Look, we've been exploring space for decades, right? But the modern push for Mars, it's framed in a totally different way. Why do people keep calling it an insurance policy? I'll give you a hint. Think bigger than just planting a flag and collecting rocks. If you are thinking about survival, you've hit the nail on the head. See, the whole point is that our home planet is, well, it's vulnerable. Could be a giant asteroid, a supervolcano, or heck, something we do to ourselves. Having all of humanity in one basket is a massive risk. So the vision, really championed by people like Elon Musk, is to create a self-sustaining backup on Mars. It totally reframes the mission from just pure exploration to a logical strategy for the long-term survival of the human species. All right, question 2. Let's get physical. Imagine you just stepped out onto that red dust. Your body would immediately feel weird, lighter. So how different is it exactly? And what are the 2 biggest medical problems this change creates for anyone wanting to live there long-term? There's your number, just 38%. You'd be living in a fraction of Earth's gravity, and that sounds fun, but it's a huge biological problem. Without that constant pull of Earth's gravity, 2 big things start to happen. Your body starts losing bone density, almost like a rapid onset osteoporosis, and your muscles, especially the big ones in your legs and back, they just begin to waste away. Figuring out how to stop that is one of the biggest medical challenges of the entire mission. So, let's say you figured out the gravity problem. There's another danger you can't see, you can't feel, and you can't hear. Earth has these amazing protective shields that Mars just doesn't have, leaving colonists totally exposed. What is this invisible threat, and how in the world do we plan to stop it? The invisible killer? It's cosmic radiation. Without a global magnetic field or a thick atmosphere, Mars gets blasted by high-energy particles from deep space and from our own sun. Now, the most practical solution isn't to drag heavy lead shields all the way from Earth. No way. It's to use what's already there. They call it passive shielding. Basically, you just pile up the Martian soil, or regolith, a few meters thick on top of your habitat. Or, even better, you just build the whole thing underground. Okay, you're safe from radiation. Now, you kind of need to breathe. And look, shipping tanks of oxygen from Earth for an entire colony, it's a non-starter. It's impossible. Luckily, a really cool experiment has already proven that we can make our own air on Mars. So what's the key ingredient it uses? An ingredient that's literally everywhere? You got it. It's carbon dioxide. The Martian atmosphere is 96% CO2, and this little experiment, MOXIE, which is on the Perseverance rover, it used electricity to literally crack those CO2 molecules open, producing pure oxygen. But here's the truly brilliant part. This isn't just for breathing. This tech lets us make liquid oxygen right there on Mars, which just happens to be the main oxidizer you need for the rocket to make the return trip home. It's a total game changer. So you've got air, now you need food. You'd think you could just start a farm, right? I mean, the Martian soil has a lot of the minerals plants need. But there's a catch. There's a toxic chemical spread throughout the soil that could poison both the crops and the colonists. Do you know what it is? The nasty culprit is a group of salts called perchlorates. They're bad news for humans and for plants. So, before anyone can plant the first Martian potato, that soil has to be treated. And scientists are already working on ways to do it. Things like literally washing the soil to rinse the salts out, heating it up to break them down, or even using special bacteria to clean it up. Okay, we've talked about how to survive on Mars, but none of that matters if you can't afford to get there in the first place. Right now, it's astronomically expensive. So what is the single key innovation in SpaceX's Starship that completely flips the financial script? 2 words: full reusability. This right here is the revolution. For decades, we've built these magnificent rockets, used them once, and then dumped them in the ocean. It's crazy. Starship is designed to be totally and rapidly reusable, just like an airplane. When you stop throwing the rocket away every single time, the cost to launch could drop by a factor of 100, maybe even more. This is the thing that turns the idea of sending thousands of people from sci-fi into a spreadsheet. So SpaceX is kind of taking a go for it, direct to Mars approach. But NASA's playing a bit of a longer game. They're planning to use another world as a testbed, a proving ground to work out all the kinks before they head to the Red Planet. What is that stepping stone? And what's the official name for this strategy? That's NASA's Moon to Mars plan. Through the Artemis program, they're going back to the moon to stay. And it makes perfect sense, right? The moon is only a few days away. It's the perfect, relatively low-risk place to have a full dress rehearsal. They can perfect deep space habitats, life support, and using local resources before they commit to that long, dangerous 9-month voyage to Mars.
All right, let's talk about a huge problem on Mars: power. Solar panels are great until a giant dust storm rolls in and blocks out the sun for months. And this isn't a theory. It's what happened to the Opportunity and InSight rovers. So what is NASA's trump card for reliable, nonstop power no matter what?
And that trump card is nuclear power, specifically a project called Kilopower. Now, don't think of a giant power plant. This is a compact fission reactor, about the size of a person, designed to pump out a steady stream of power for over a decade. It doesn't care if it's day or night, or if there's a planet-covering dust storm. This is the baseline, the guarantee that the lights and the life support stay on when the sun goes away.
Now for a question that's less about engineering and more about a really profound ethical and scientific issue. When we go to Mars, we have this massive responsibility not to mess it up before we even get to understand it. So what is the international principle that governs this whole idea? It's called planetary protection, and what it's really about is preventing something called forward contamination. Think about it. If we accidentally bring Earth bacteria to Mars and it survives, we might completely ruin our chance to answer one of the biggest questions we've ever asked. Are we alone? Any life we find after that might just be, well, us? That's why every spacecraft we send to Mars goes through this incredibly intense sterilization process. All right, we've made it to the final question. We've covered the why, the how, and all the what-ifs. Now, for the when. If you put all these plans and all this amazing technology together, what is the earliest decade that experts think we could actually see the first human footprints on Martian soil? The 2030s. I know, it sounds crazy close. If the super ambitious timelines from groups like NASA and SpaceX actually hold up, we could be watching that historic moment unfold sometime in the next decade or so. But, and this is so important to remember, that first landing is just the start. That's the Apollo 11 moment. The real journey, the journey to a truly self-sustaining city on another planet, that's a century-long adventure.
And that is it. That's the quiz. If you got all 10 right, then seriously, congratulations, you are officially a Mars colonization master. As we've just seen, this isn't some fantasy for the distant future. It's a real project tackling real, immense challenges with the goal of securing a future for all of us beyond Earth. You know, you're no longer just a spectator to all of this. You're an informed witness to what might be the greatest adventure in human history. The work is happening now. The problems are being solved today. So the final question isn't for me to answer. It's for you to think about. As this incredible story unfolds in our lifetime, what will you see?